Hi, welcome to our next level 1 tables, equations and graphs video. We move into parabolic functions now, and this first video on parabolics is an introduction. So far all our efforts have been put into straight line graphs. Y equal to m times x plus c. Well, now we're going to talk about parabolas, but first of all let's talk about this word quadratic. A quadratic is an expression that has the highest power of 2. So first example here, that's a quadratic because x squared plus 4x has got an x squared. The second example, it's got a 3x squared. Doesn't matter if it's a 3x squared, it's still got an x squared. The third expression is not a quadratic. It's a linear function, by the way. It's mx plus c. Doesn't have an x squared in it. And our fourth example is not quadratic because even though it does have an x squared in it, the highest power is x to the power of 3. So not a quadratic. Right, now we've talked in the algebra unit about parabolas that are in factored form, 2 brackets being times together, and we've shown you how to expand them into expanded form. When we draw the graph of a quadratic function, we get a graph called a parabola, or parabola, some people like to call it. This is what a parabola looks like. It's not a straight line graph. Now, parabolas are very useful in many applications. I'll just give you a few just to make you understand how vital these are. They're used in construction. They're used in any type of projectile motion or analysis of motion. They're used in entertainment. They're definitely used in logos. And without parabolas, there's no way you would have the technology or the communication we have today that uses cell phones and satellites. Right, so let's talk a little bit more about the parabola graph. We can move it around. We're going to teach you how to move it around. Instead of being at the origin, we're going to move it around to different locations. We'll show you how all that works in an upcoming video. This point here is called the vertex. It's the bottom of the parabola. But if the parabola is being inverted upside down, and we'll show you how to do that as well, the vertex stays at the top. So the vertex is either the bottom or the top of the parabola. We are going to use words like the maximum point or the minimum point in the next few years, and you might want to start getting used to those words now. The minimum point is the bottom of the parabola. The maximum point is the top of the parabola. Right, we have an axis of symmetry. It's just like a mirror line. It's like a vertical line. Now, eventually you are going to learn how to take the parabola and turn it on its side or turn it on angles. But for now, we're just going to keep the parabola upright. And therefore, this vertical line that goes through the vertex, by the way, is called an axis of symmetry, a mirror line. And it's the same shape on both sides of the mirror line. Now, see this line that I've drawn onto the parabola? That represents the steepness of the parabola at a particular point. But what's going to happen as the points move around, the gradient or the steepness of that line changes. So the parabola comes down to the minimum point here and then climbs itself back up with a gradient and changes in that direction there. So you can see it's a nice smooth curve that comes down. It gets to a 0, so you have to make sure it's really smooth at the bottom, a 0 flat, and then it starts to climb back up again. We're going to talk a lot more of that, especially at level 2. Right, well that's us for our first introductory video on parabolas, so thanks for watching.